Hey guys, welcome back. Today is day 34, and today we're going to learn how to solve linear systems by substitution. So last class we learned how to graph two lines, and we looked at where the two lines intersected. So that was linear systems by graphing. Today we're going to learn a way to do it algebraically without graphing. So how we're going to do that is to first solve one of the equations for one of its variables. Okay, and it's not going to matter which variable. Remember, with the system of equations, you're going to have two equations with two different variables. When possible, solve for a variable that has a coefficient of 1. Okay, coefficient, remember, is the number before the variable. So if it's 1, it's not even going to be there. Okay, so the second step will be then to substitute the expression. So we're going to substitute the expression from step 1 into the other equation and then solve for the other variable. So this will be a little more obvious when we start doing some examples. Okay, we're then going to take that and substitute in, the value from step 2 into the revised equation from step 1 and solve. And then always, fourth step, we're going to check our answer. Okay, so what does that mean? What it means is we're going to look at the system of equations. We need to pick out, which of these has a coefficient of 1. Well, if I look at this one right here, we have 1y and 1x. So both of those we could use x or y, but it's easier to actually solve for y in the first example because it's already solved for y. So watch what we're going to do. We're going to solve for y since equation 1 is already solved for y. Y is equal to 3x plus 2. We're then going to substitute the 3x plus 2 for y in equation 2. What that means, what I like to do is circle in the second equation that y. See how we're saying y equals? So now we're going to circle that y, and instead of a y, we're actually going to put in 3x plus 2. So watch, this example right here, we've got x plus 2. Instead of 2y, we're going to write 3x plus 2. And that's going to be equal to 11. So notice, now we only have one variable. So it's easier, when we have one variable to now solve for it. So it's equal to 11. And we're then going to substitute in 3x2. So we're going to write equation number 2. Plus 2 for y, kind of ran out of space in this one. Hold on. Hey guys, welcome back. We're on day 34, and today we're going to learn how to solve linear systems by substitution. So last class we talked about solving linear systems by graphing. We graphed the two linear equations and we looked at the point where the two intersected. So this is another method for doing it. So this is called substitution, and this is how it works. So the first thing we're going to do is we're going to solve one of the equations for one of its variables. When possible, solve for a variable that has a coefficient of 1. Remember, the coefficient is the number before the variable, like 3x. But a coefficient of 1 would actually be invisible, so it would just be an x. Just keep that in mind. Or it could be a y. So step 2, we're then going to substitute the expression from step 1 into the other equation and solve for the other variable. So we're going to substitute in, the expression from step 1 into the other equation. And then step 3, we're going to substitute the value from step 2 into the revised equation from step 1 and solve. And then, of course, we're always going to check our answer. Now, this should make it a little easier when we do an example. So our first example, we have a linear system. We've got two equations, equation 1 and 2. We look for a coefficient of 1. So here we have a coefficient of 3. Here we have a coefficient of 1. Here we have a coefficient of 1. Here's one of 2. In this example, we're already solved for y. So we're going to that's going to be the easiest one. So equation 1 is already solved for y. So we don't need to worry about solving for it. So we're just going to use y is equal to 3x plus 2 as our first step. We're going to take this 3x plus 2. Now this is important. I like to notice we solved for y here. So I'm going to circle the y here. Okay, because you're going to look into the second equation, whatever variable you solve for. Now you're going to substitute in this 3x plus 2 for your y. So we have our x plus 2 times, and instead of the y, we're going to say 3x plus 2. And that's going to be equal to 11. So notice now we only have one variable. Once we have one variable, we can solve for it. We just go back to DC Mam, we distribute. Okay, we combine our like terms. 7x plus 4 is equal to 11. We're going to subtract the constant here. 7x is equal to 7, and then we're going to divide by the coefficient. Our x is equal to 1. Okay, so we're halfway there. We already know the x ordered pair. It's 1. Okay, but we need to figure out the y. So to figure out the y, we then go back to the first. We know our x is equal to 1, so we're going to plug it back into the equation number 1 and substitute that 3x plus 2 in for that y. Okay, so let's figure it out. We're going to go to step 3. So we substituted in 3x plus 2 for the y. Okay, so the next step is step 3. All right. We're going to substitute the 1 that we got for our x into the original equation to find the value for y. So y was equal to 3x plus 2, so our x is 1. So when we do that, 3 times 1 is 3, 3 plus 2 is 5. So our solution is 1, 5. Okay, now to check our work, we can go back to the original two equations, and this would have been a little bit easier if we could have gotten it on one page, but it wasn't possible. We're going to plug in 1, 5. So 5 is equal to 3 times 1 plus 2. Does that work? Yes, it does. Okay, 5 is equal to 5. All right, and the second equation was x plus 2y is equal to 11. We plug in our x is 1 plus 2 times 5 is equal to 11. That works as well. 1 plus 10 equals 11. 11 equals 11. So we know it works, okay? So we're going to try some more examples. All right, at any point, please pause the video and try some yourself. Okay, when I look at the first number 1 example, I'm looking for a coefficient of 1. So here, my y value has a coefficient of 1. I need to solve for y first. Y is going to be equal to 5x, 5x minus 2, sorry. 5x minus 2. All right, because I solved for y there, I like to circle my y here. Okay, I'm then going to substitute the 5x minus 2 for my y. So I'm going to rewrite that second equation. All right, notice instead of a y, I now have that 5x minus 2. I'm going to distribute. All right, and I'm going to combine my like terms. Oops, that should be minus. Sorry, that's not minus 12x. It's just minus 12. Okay. All right. 27x minus 12 is equal to negative 12. All right. Now I'm going to add 12 to both sides. So my 27x is going to be equal to 0. When I divide by the 27, my x is going to be equal to 0. Okay. I then take that x and I plug it into that original equation. So my y is equal to 5 times x is now 0 minus 2. Our y is 0 minus 2, so our y is negative 2. There's the ordered pair, okay? 0, negative 2. All right, then I take it and I actually plug it back in and do my check step. So negative 5 times 0 minus 2 equals negative 2. That will work. All right, so I know that one works. And then the second one is negative 3 times 0 plus 6 times negative 2 equals negative 12. And that one works. Okay, so those are your steps. All right, let's look at number 2. All right, so here, the one to solve for would make sense. The only one that has a coefficient of 1 would be the x right here. So we're going to look at the first equation and we're going to solve for x. X is going to be equal to negative 3y plus 1. We just brought the 3y to the other side. All right, because we solved for x, I'm going to circle my x here. And now I'm going to substitute in negative 3y plus 1. So negative 3 times negative 3y plus 1 minus 3y is equal to negative 15. All right, when I distribute, I get 9y minus 3 minus the 3y is equal to negative 15. I'll combine my like terms. 6y minus 3 is equal to negative 15. And then I'm going to add my 3 to both sides. Okay, I'm going to get 6y is equal to negative 12. All right, divide by 6. My y is equal to negative 2. I'm halfway there. Now to get the x, I simply take that negative 2 and plug it back in here. My x is going to be equal to negative 3 times negative 2 plus 1. X is going to be equal to 6 plus 1, which is 7. So my ordered pair would be 7 is my x, negative 2 is my y. Okay. For purposes of space here, I'm not going to do the check step, but the answer key that we have out there for 34A has all the check steps in it. So again, you take the 7, negative 2, plug it back into both of these equations and make sure that it works. All right, so moving on, let's look at number 3. All right, maybe you want to pause it, okay? If I look at both of these examples, I can see that the second equation has a coefficient of 1. So I'm actually going to solve for y. Y is going to be equal to positive 5x plus 19. All I did was bring the 5x to the other side. Okay, because I solved for y there, I'm going to circle the y in the other equation. And now I'm going to substitute in the 5x plus 19 where that y is. Negative 3x minus 8 times 5x plus 19, and that's going to be equal to 20. Okay, so now at this point, I have just one variable, so I can solve for it. I'm going to distribute, and that's going to be minus 152 is equal to 20. I'm going to combine my like terms. Negative 43x minus 152 is equal to 20. Then I add my 152 to both sides. Okay, I get negative 43x is going to be equal to 172. When I finally divide by negative 43, all right, I'm going to find out that my x value is going to be equal to negative 4. All right, so we're halfway there. I take that x equals negative 4 and I plug it back into that expression there and solve for y. Y is equal to 5 times negative 4 plus 19. So y is equal to negative 20 plus 19. My y is equal to negative 1. So my solution is my x is negative 4, my y is negative 1. All right, again, you can take it and plug it back into both equations to do your check step. All right, so number 4. All right, if I look at number 4, I'm going to solve, in this particular example, I'm going to solve for y, because here's my coefficient of 1. So y is going to be equal to x plus 3. Okay. So because y is equal to x plus 3, I'm going to circle my y here and substitute in the x plus 3 in the first equation. Negative 3x plus 3 times x plus 3 is going to be equal to 4. When I distribute, okay, I end up with the 3x's canceling out. I've got 9 is equal to 4. Well, 9 does not equal to 4, so I know there's no solution. So here's an example of no solution, which we know happens when the slope of both of the equations is the same. Okay, looking at number 5. All right, number 5, we're going to, when I look at it, I don't have any coefficients of 1, but I do have one of negative 1. All right, so I'm going to solve first for negative b is equal to negative 2a plus 5, but then I'm going to divide everything by negative 1. B is going to be equal to 2a minus 5. Okay, so I'm then going to substitute in the first equation for that b. So I've got 2a minus 3 times, instead of b, I'm going to put 2a minus 5, and that's going to be equal to 7. I'm then going to distribute 2a minus 6a plus 15 is equal to 7. All right, my 2a minus 6a is a negative 4a plus 15 is equal to 7. Then I subtract the 15 from both sides. Negative 4a is going to be equal to negative 8. All right, when I divide by negative 4, my a is going to be equal to 2. Okay, so then I'm going to take the 2 and plug it back in okay, to get the b. My b is going to be equal to 2 times 2 minus 5. 4 minus 5 is equal to -1. Now, because we don't have an x and a y, we have an a and a b, we're going to put the ordered pairs in alphabetical order, a and b. So this would be, in this case, 2 and -1. Okay? Again, then you can take it and plug them in and do your check step. All right? Example number 6, all right? I notice my y is already solved here for 2x minus 4. So that makes it easiest just to substitute into that y. 4x minus 2 times 2x minus 4 is going to be equal to 8. Okay, so I just took the 2x minus 4 and substituted it right there. Now when I distribute, it's 4x minus 4x plus 8 equals 8. All right, the 4x minus 4x cancel out. I'm left with 8 equals 8. That's a true statement, so I know my answer is infinite solutions. That means those linear equations are the same thing. They're right on top of each other. Okay, so that gives us an example of each type. All right, now let's look at some word problems. Okay, this says, find the value of two numbers if their sum is 12 and their difference is 4. Okay, sum is addition, difference is subtraction. Okay, remember our let statement. Okay, we need to know our two numbers. We're finding two numbers. So let's let, okay, x be equal to the first number. All right, and let's let y be equal to the second number. All right, when you have two different variables, you need to have two different equations in order to solve them. Okay, so the first equation, so you know that in your mind, you've got to come up with two equations from this word problem. If their sum is 12, I know that if I take my first number and my second number and I add them together, I'm going to get 12. There's my first equation. The second says the difference is going to be 4. So if I take my first number and I subtract my second number, I'm going to get 4. All right. So I need to solve, and it doesn't matter which one. We have a few coefficients of 1. Okay, in this example, I'm going to solve for y. In the first one, I get -x plus 12. Okay, so now, or you could say 12 minus x, it doesn't matter. All right, I'm then going to substitute it in here. So I get x minus -x plus 12, and that's going to be equal to 4. All right, this would be x plus x minus 12 is equal to 4. All right, I'm going to add the x's together. I get 2x minus 12. I combine my like terms. I'm going to add the constant to both sides. 2x is going to be equal to 16. When I divide by 2, my x is going to be equal to 8. All right, I'm halfway here. There, I know my first number. My first number is going to be 8. And my second number, I plug it back in, is going to be y is equal to -8 plus 12, or y is 4. Okay, so my answer would be, the two numbers would be 8 and 4. Okay, so with the word problems, you're not necessarily going to have an ordered pair. You need to specify which is which. So this is just saying find the two values. Okay. Looking at the next example, it says your brother and sister took turns driving on a 635-mile trip that took 11 hours to complete. Your brother drove at a constant speed of 60 miles per hour and your sister drove at a constant speed of 55 miles per hour. Let x be the number of hours your brother drove and let y be the number of hours your sister drove. Well, in this case, they gave us the let statement. X is equal to hours for the brother. Okay, and y is the hours for the sister. Okay, there's our let statement. All right, find the number of hours each of your siblings drove. Okay, so now we know we have two variables. That means we need two equations. Okay, so sometimes the second equation is there. It's a little bit harder to pull out. All right, but it's here. It says the trip took 11 hours. That means the number of hours the brother drove and the number of hours the sister drove would be 11 hours. Okay? One of the equations is usually pretty easy. Now the second one, all right, if the brother is driving at 60 miles an hour, that's 60x. And the sister is driving at 55 miles an hour, that's 55y. okay? And they're driving for a total of 635 miles. So there's our second equation. All right, so I'm going to use the first equation. I've got a coefficient of 1 first. Let's solve for y. My y is going to be equal to negative x plus 11. Because I solved for y there, I'm going to circle it here and substitute in negative x plus 11 for that. So 60x plus 55y times a negative x plus 11 is going to be equal to 635. All right, so now I'm going to distribute. Okay, whoops, I made a mistake here. It's not 55y, it's just 55. Silly me. It's like all of a sudden I said, why do I have two variables? At this point, you should only have one variable. Okay, so this is going to be 60x minus 55x when I distribute, okay, plus 605 is going to be equal to 635. All right, I'm going to combine my like terms. I end up with 5x plus 605 equals 635. I'm going to subtract the 605 from both sides, and I get 5x is equal to 30. I divide by 5. My x is 6. Okay, so now I can plug it back in, and my y is going to be negative 6 plus 11, which is 5. So my sister is 5, my brother is 6. Okay, so I'm going to write it out as brother drove 6 hours and sister drove 5 hours. Okay. All right, so the key to it is identifying the two variables and then the two equations. All right, moving on to the next one. It says the members of an outing club take a day-long tubing trip down a river. Okay, the company that offers the tubing trip, okay, charges $15 to rent a tube for a person to use and $7.50 to rent a cooler tube, which is used to carry food and water in a cooler. The club members spend $360 to rent a total of 26 tubes. How many of each type of tube did they rent? Okay, so let's start with our variables. Let's let x be equal to the tube. We don't know how many tubes. And then let's let y be the cooler tubes. Okay. All right. Now we know we rented a total of 26 tubes. So the first equation is pretty easy. X plus y is equal to 26. Okay. And the second equation, all right, we're dealing with money. Okay, it's $15 to rent a tube for a person. So that's going to be 15x. Okay, and then $7.50 for the cooler tubes each. So it's $7.50 times your y, and that's going to be equal to $360. So there's our two equations with our two variables. We identify the variable that has a coefficient of 1. In this case, I'll solve for y. All right, because I solve for y, I'm going to plug it in right there. So this is going to be 15x plus 7.5 times negative x plus 26 is going to be equal to 360. We're going to distribute 15x minus 7.5x, okay, plus 195 is going to be equal to 360. Okay, we're going to combine our like terms. 7.5x plus 195 is equal to 360. All right, we're going to subtract the 195 from both sides. Our 7.5x is going to be equal to 165. When we divide by 7.5, oops, running out of space here. Let me move this down a little bit. Hold on. Okay, I'm going to do it over here. 7.5x is equal to 165. I'm going to divide by 7.5. All right, our x is going to be equal to 22. All right, that means, and I like to write it up here, we've got 22 tubes. Now I'm going to plug that in to this equation right here. My y is going to be equal to negative 22 plus 26, or my y is going to be 4. All right, so that's how we get 22 tubes and 4 cooler tubes. Okay, so I hope that helped. All right. And you should practice with 34B. Thank you. Bye-bye.